Today we're going to talk about how we draw light rays, and we're going to be doing this for quite a while, but today specifically about light rays for color, different colors, and so we can depict how different colors of light mix to form other colors. All right, so here, the first page is just some general information. Remember, we have our primary colors of light, which are red, green, and blue. So this is not of paints and dyes, but of light. The secondary colors are yellow, cyan, magenta, and you get those by mixing two of the primary colors. So again, and this is not mixing paint, this is adding light together. So if you add red and green, you get yellow. If you add green and blue light, you get cyan. If you add red and blue, you get magenta. And we also have white light can be made by mixing red, green, and blue. And you know that if you mix red, green, and blue paints or dyes, you'll get black or brown. But that's because those are each subtracting different colors. Whereas if you're adding light, you add red to green to blue, you get white light. And black light is the absence of color. So if everything is absorbed or blocked out, you have black. Okay, and how we draw rays of light is just as an arrow. Okay, so an example over here, red light coming off of this stoplight here. We draw the light coming off the stoplight as an arrow. And I've drawn it here as a red arrow with a little R under it. We'll always label all of the arrows, and we'll only have red, green, and blue. But I drew it as a red arrow. You could also draw it as just with your pencil or with your pen, and as long as you label it R, then I know that it's red. If you come over to the yellow light, remember that yellow is a mixture of red and green. So when we draw light coming off of a yellow source, we'll draw the red and the green arrow and label them R and G. We have light coming off of a green source. We'll draw a green arrow and label it G. Okay, white light is drawn labeling a red arrow, a green arrow, and a blue arrow, R, G, B. We have some other terminology that we need to use about drawing and mixing and adding light. We draw, like here on the left, we have reflection, and we talked about this with the red balloon, and that things are the color they are because of the light that they reflect. So here I have a green light source, so it's drawn as a green arrow labeled G. It hits the green tennis ball, and the reason the tennis ball is green is because it reflects green light to your eyes. As long as there is green light available, it will reflect it so that you can see the tennis ball is green. Okay, that's reflection, color by reflection. Another one is like a filter, so you have color by transmission, light passing through, in this case, a piece of red glass or plastic or something that is transparent but has a color to it. And like red glass is red because it simply allows red light to pass through. It would absorb blue, absorb green, but let red light pass. That's why you would see it as red. So any source of light that has red in it, like white or magenta or red, that light ray, but this is a red light, so we have a red arrow labeled R, and it passes right through the red glass to your eye. That's why you see the glass is red, because it allows red to pass through it. Absorption it works for both of these. Like in the first one, the green tennis ball is reflecting green, but it would absorb blue and red. The red glass is allowing red light to pass, but it absorbs blue and green. And the way we draw that is with a little circle. When light is absorbed, we draw it with a little circle. So we have a cyan light source, and cyan is the mixture of green and blue light. So we would draw it as a green and a blue arrow, labeled G and B. And the green is being absorbed when it hits the blue bucket. The bucket is blue because it reflects blue and absorbs everything else, like green and red. So we draw it absorbed as a green circle, and the blue light hits the bucket and reflects to your eyes. That's why it's blue, because it reflects blue and absorbs the other things. Down here we still have a cyan light, so we still have a green and a blue labeled G and B, and a piece of green glass. You'll note that the green goes straight through to your eye. That's why it appears to be green. The blue, however, is absorbed, so we draw it as a circle. If you don't have a colored pencil or something, you're doing this on paper with a pencil pen, you can just draw it as a pencil colored circle. That's perfectly fine as long as you label like the arrow with a B, so I know it is blue hitting there and being absorbed. Okay, so we're going to run through a bunch of examples here. So this is the first one, and we're going to draw all the rays coming from the light source, all the rays that are there. This is white light, so that is red, green, and blue light all mixed together. So we're going to draw the rays, and they're going to be impacting the object. So we've got green hitting, and it's being absorbed. The object is red, so it absorbs green. We have blue light, a ray labeled B. It hits the object, and it's being absorbed, so I put a little blue circle. Now red light, labeled R, is a red arrow, hits the object, and it's not absorbed, it's reflected to your eye. So this circle looks red because it's reflecting red and absorbing all the other colors. And the person then sees red. Even though there was white light available, the only light that makes it to their eye is red. Okay, here we have a blue object, blue folder, blue book. White light is still green, which gets absorbed by the blue. Blue, which hits the object. Red, which hits the object and gets absorbed. And the blue bounces off. So the object is blue because it reflects blue and absorbs red and green. So this person, even though all the colors are there, red, green, and blue, sees the object as blue because blue is what's reflected and red and green are absorbed. Here we go. We have a transparent object, just like a liquid in a cup, a green liquid in a cup. Again, white light is present, which means it's red, green, and blue. The green would simply pass right through to the eye. The blue gets absorbed. The red gets absorbed. That's why it appears to be green, because the green passes through, the blue and the red are absorbed, so the person sees green. We have a yellow shirt, and remember, something that is yellow, like this shirt, would be yellow because it reflects red and green. Yellow is a combination of red and green light. So in order for this person to see the yellow shirt as yellow, it has to have red and green light available. Okay, we have a flashlight here with white light. So it's green, which hits the object. Blue, which hits the object and gets absorbed. Red, which hits the object and reflects the same as the green reflects. So again, this object is yellow as long as there is both red and green light available for it to reflect. There is in this case, so the person's eyes picks up red and green frequencies. Your brain makes up yellow. The blue has been subtracted, has been absorbed by the shirt. Okay. Here we have a white light and a magenta filter or piece of glass. So white light again is green, which gets absorbed, blue, which passes through magenta, and red, which also passes through magenta. If you remember from the beginning, magenta is the mixture of red and blue light. So in order for this person to see it as magenta, red and blue has to be available, and they will both pass through the filter. The green gets absorbed. So what started out as white light, this person through the filter sees magenta. Now we have a white light, and we have a cyan filter and a blue filter. So we got the white light, which is a mixture of green, which passes through the cyan and gets absorbed by the blue. Blue, which passes through the cyan. Remember, cyan is a mixture of green and blue. So both the green and the blue get through. And when you get to the blue filter, well, the blue will pass right through, and the green will be absorbed. The red gets absorbed at the cyan. the cyan filter allows blue and green to pass but absorbs red. The blue absorbs red and green. It would absorb red if there was any there, but there's not. The green gets absorbed, the blue passes through, so the person sees blue. It is a mixture of red, green, and blue through these two filters that the person only ends up seeing the blue. Okay, now we have a white light, which will pass through a cyan filter and a yellow filter, and will determine what the person can see. So remember, white light means red, green, and blue. So if we have green, the green will pass right through the cyan because cyan lets green and blue pass. It'll pass through the yellow because, remember, yellow is a mixture of green and red. So the green gets through both filters. The blue passes through cyan. Cyan is a mixture of blue and green. They both get through here. But when it gets to the yellow, yellow is a blue absorber. Yellow allows red and green to pass, but absorbs the blue. And the red never has a chance to pass through the yellow because it is absorbed at the cyan filter. So this person down here, even though white light is available, the only light that gets through both filters is the green. Here we have a cyan and a red filter. So remember, the cyan filter will allow blue and green to pass. The red filter will only allow red to pass. So we have white light, where we have a green ray, which passes through the cyan filter, hits the red filter, and gets absorbed. The blue passes through cyan, but gets absorbed at red. So here we have a cyan filter that absorbs red and lets blue and green pass, so both blue and green pass. But when you get to the red only lets red light pass, transmit through it, and absorbs blue and green. So we have the red light, which gets stopped at the cyan filter. Cyan only lets blue and green pass. So this person sees black. They see the absence of light and color. Okay, here we go. We have some just reflection here. We have a yellow light. And remember, yellow light means a mixture of red and green. And it's going to be incident or hit this green piece of paper. And we'll see if any of it will make it to the observer's eye. So we have yellow, which means we have green. And obviously things that are green because they reflect green light. So we have green and red both hitting the surface. Green and red are yellow. The red gets absorbed because that's what green things do. They absorb red and blue and reflect green. So this person sees this object is green because there is green light available. As long as there is green light available, this object will appear green. Still on yellow light, so still have red and green, and we have what looks to be a magenta hat. So light will reflect or be absorbed at the magenta hat, and if it's reflected, it'll make it to the eye, and we'll see that color. Okay. So we have green, which magenta reflects red and blue, but absorbs green. So the green does not reflect off of the hat. Red light, yellow is red and green. When the red hits the hat, well, magenta things will reflect both red and blue as long as they are available. In this case, there is no blue, but the red will reflect to the eye. So this person will see the magenta hat as red. Here we have a red light, so no blue or green, just red hitting a cyan colored hat. So just red light. Remember, cyan is cyanic because it reflects green and blue. But there is no green and blue available, just red, and the red is absorbed by the cyan hat, so this person sees the hat as black. It can't see green or blue or cyan because those colors are not available to reflect. Okay. Here we have a green alligator. And then we have a cyan filter. So the light's going to come, the cyan light, so blue and green, are going to come out of the flashlight there, hit the alligator, possibly be absorbed, possibly reflected through the cyan filter to the eye. And remember, cyan will let blue and green pass but absorb red. Okay, so cyan is a mixture of green. It's going to hit the alligator. And blue, which is also going to hit the alligator. But green objects will absorb the blue and red if it's there and reflect the green. The green light will pass right through the cyan filter because cyan is a mixture of green and blue. Okay, so through a cyan filter, the green alligator will look green because there is green light available that reflects off the alligator and goes right through the cyan filter. So this person sees green. Okay, now we have white light, red, green, and blue, passing through a yellow, a cyan, and a magenta filter before the light can get to the person. Remember, white is green. Green will pass through the yellow, pass through the cyan, but get absorbed by the magenta. So yellow is a mixture of red and green, so it will let the green pass. Cyan is a mixture of blue and green, so it will let the green pass. Magenta is a mixture of red and blue, so the green gets absorbed. The blue light gets absorbed right at the yellow. Yellow is a blue absorber. So yellow is a mixture of red and green, and so the blue is absorbed. You go to the red light, yellow will let red and green pass. Cyan stops red. Cyan is a mixture of green and blue. The red is absorbed, so the person sees black. Okay. Now we have what looks to be a white duck. So it being white, it would reflect all colors as long as all colors are there. But whatever colors are available, it will reflect it. So the green one the green light will come out, a green arrow labeled G. The red light will come out, a red arrow labeled R. Okay, remember, because it's white, it will reflect all colors. So the red gets reflected to the eyes, the green gets reflected to the eyes. And remember, if your eyes pick up both red and green, your brain makes up yellow. So this white duck is yellow because there are only red and green available. If we added a blue light in there, well, then the duck would be white. Now we have a banana peel, which is yellow as long as colors that make up yellow, red and green, are available. Here we have a green light. The green strikes the banana. The blue strikes the banana, and remember, the blue will be absorbed. Yellow is a mixture of red and green, and it is a blue absorber. The green will get reflected because yellow is a mixture of red and green. In order for it to be yellow, it must reflect both red and green. There is no red available, so it still reflects the green, and the person sees the yellow banana as green. All right, now we have two different white sources passing through a red glass filter and a cyan glass filter, striking a white screen and maybe reflecting, maybe absorbing some things. So remember that white is a mixture of green, and the red glass will absorb the green. Blue, and the red glass will absorb the blue. And red light, which will pass right through the filter. The filter is red because it allows red light to pass and absorbs everything else. And the red gets reflected to the observer's eye. Okay, then the other one, we have green light, which passes right through a cyan filter because cyan is a mixture of green and blue. So the green gets reflected to the eyes. Right now the person is seeing yellow. So before this, the person could see red. And now that the green is also gets through, that means that's yellow. The blue light also passes through cyan, strikes the screen, and gets reflected. Now the person is seeing red, green, and blue light. That means the person is seeing white. All those colors are adding up to white, but we still have the red coming out of the flashlight, and it gets absorbed right there at the cyan filter. But the person sees white because red is coming through the red glass, and green and blue are coming through the cyan glass. Okay, so here we have basically the same setup with a cyan light passing through a magenta filter and magenta light passing through a cyan filter. So remember, cyan is blue and green, so we're certainly going to have green light, but the green light gets absorbed by the magenta filter. And blue light, which passes right through magenta filter, would allow red and blue to pass through and absorb the green. So the blue goes on to hit the white screen, which reflects all colors, including blue. The magenta is blue light, which passes right through a cyan. Cyan would let blue and green pass. So the blue makes it through, so now we have nothing but blue from both sources, and the red for magenta. Once you get to the cyan filter, the red is absorbed, so this person sees blue. Okay. Now we have the same basic physical setup, but with white light passing through a yellow and a blue glass filter. And now the screen is magenta. White means we have red, green, and blue. The green passes through a yellow filter and gets absorbed at the magenta screen. The blue gets absorbed at the yellow filter. And the red passes through the yellow glass filter because yellow allows both red and green to pass. The green got absorbed at the magenta filter, but the red gets reflected to the eye. For the other one, we still have red, blue, and green. The green gets stopped at the blue glass because blue only allows blue to pass. The blue goes right through, hits the screen, and reflects to the eyes because magenta reflects both red and blue. Then the red gets absorbed at the blue. Blue only allows blue light to pass, so the red is absorbed. So the person sees red and blue together, which your brain turns into magenta. Okay. Now we have almost the same setup. We have a white light passing through a green filter and a white light passing through a cyan filter, and then there's this red visor or a red filter. See how much light can get through to the person. So white means red, green, and blue. The green will pass right through the green filter but get absorbed at the red filter. The blue will get absorbed at the green filter, and the red will get absorbed at the green filter. So the green only allows green light to pass through, but then the red visor stops the green light. And then you come on down to the white flashlight. Cyan allows green to pass, but the red filter absorbs it. Cyan allows blue to pass, but the red filter absorbs it. Red gets absorbed by the cyan filter, so no light is getting to the observer, so this is seen as black, or the absence of color and light. Okay, then we have one with three sources: a yellow source, which we know is red and green, a magenta source we know is blue and red, and a cyan that we know is green and blue, all passing through cyan, yellow, and magenta filters and bouncing off of a cyan screen. This one's complicated. So we have yellow, we have red and green. The green gets through the cyan filter, hits the cyan screen, and gets reflected because the cyan allows blue and green, but there's only green. And then the cyan screen would reflect blue and green, but there's only green available, no blue, so the green gets reflected. Magenta is a mixture of red, which goes through yellow and gets absorbed, blue, which gets absorbed at the yellow filter, and then we have magenta, cyan, which is a green and blue, passing through a magenta filter. The green gets absorbed at the magenta filter because it would only allow blue and red if they were both available. The blue is red. It passes through, hits the cyan filter, or the cyan screen, and the blue reflects to your eyes. So we get no light from this middle flashlight because the blue is absorbed here and the red is absorbed at the screen. From the top one, only the green makes it to our eyes, and from the bottom one, the blue makes it to our eyes. So blue and green makes cyan. This person